There is a moment that happened thousands of times, on thousands of shores, across thousands of years, a person standing at the edge of the water, looking out at the sea, understanding that something is gone beneath it. Not something abstract, something specific. The place where their grandparents had built their lives, the river their father had fished, the hill where the community gathered when the rains came, the ground that had been ground, solid and familiar and named, for as long as anyone could remember. Now water. We do not know the names of the people who stood in those moments. We do not know what language shaped their grief. We know only that the moments happened, because the rising seas at the end of the last great ice age were real, and the lands they consumed were real, and the people who lived on those lands were real. And we know what those people did with what they had witnessed. They made it into a story. The story survived. They survived in the songs of the Aboriginal Australians, and in the hymns of the Vedic priests, and in the clay tablets of the Sumerian scribes, and in the philosophical dialogues of Plato, and in the navigational traditions of Polynesian seafarers. They survived in cultures that never met each other and never could have. Separated by oceans and mountain ranges and thousands of miles of open land, these traditions do not all describe the same place. They describe the same experience of losing a place. That distinction matters. And this story will honor it throughout. This is not a story about Atlantis. That word carries too much weight tonight. Set it aside. This is a story about a question that serious scientists are asking right now. With sonar equipment and satellite imagery and core samples pulled from the floor of seas that were dry land when our ancestors walked them, where did the first coastal civilizations build their lives? And what did the rising water take? Let your breathing slow. The question is longer than one night. But tonight, we begin. Chapter 1. The Fire That Came from the Water. Imagine you are standing on a beach 21,000 years ago. The sun is the same sun. The stars at night are the same stars. But the shoreline beneath your feet extends to the horizon in ways that no modern map would recognize. Because the ocean behind you is roughly 120 meters lower than it is tonight. 120 meters. The height of a 40-story building, pulled down from the world's coastlines and locked inside the ice sheets that covered North America and Northern Europe in a grip that had held for tens of thousands of years. What that lower ocean means is this. The shallow continental shelves that now lie underwater were dry land. The floor of the North Sea was a forested plain crossed by rivers broad enough to rival the Rhine. The islands of Southeast Asia were connected to the Asian mainland in a single continuous landmass, roughly the size of modern India. Australia was joined to New Guinea. The Persian Gulf did not exist as a body of water. It was a river valley running between mountains, watered by tributaries of the Tigris and the Euphrates. Opening southward toward the Arabian Sea, tens of millions of square kilometers of land, now beneath the ocean, were available to people who had been living on them for generations beyond counting. Then the ice began to melt. It did not melt smoothly. The great ice sheets released their water in pulses. Sudden accelerations, when enormous volumes of meltwater entered the ocean in periods so brief that, by geological standards, they were nearly instantaneous. The most significant of these events is called Meltwater Pulse 1A. Climate scientists and geologists place it at approximately 14,600 years ago. During this pulse, sea levels around the world rose by an estimated 4 to 6 meters within a period of a few centuries. Some regional models suggest the rise may have been more concentrated in certain coastal areas, depending on the specific dynamics of ice sheet collapse. 4 to 6 meters. Within a few centuries. Think about what that means for someone living on a coastal plain at sea level. Not in the abstract. In the specific, your grandmother was born on land that is now beneath the water. The fishing ground your father walked to is now reachable only by boat. The hill where your people gathered for ceremonies is an island now, surrounded by water on all sides, where there was once dry ground. The river mouth where your community built its houses has moved inland. And the houses themselves are gone. And the children who grew up in them are telling their own children about a place that no longer exists in any form their children can see or touch. That is not myth. That is memory. And the difference between myth and memory is what this story is about. Consider what you do with a memory like that. You tell it. You tell it in the most powerful form available to a people without writing, which is story. You give the memory the structure and the weight that will carry it across generations. Across the centuries, it needs to cross to reach the people who come after. Across the world, in cultures, with no contact with each other. The oral traditions of every people whose coastlines were touched by the postglacial sea level rise contain stories of catastrophic flooding and lost homelands. Not just the famous ones. Not just Noah and Gilgamesh. Hundreds of distinct traditions. From the Aboriginal Australians to the coastal peoples of North America to the island communities of the Pacific. Share structural similarities that scholars have noted and debated for generations. The debate about what those similarities mean is genuine and unresolved. Some researchers argue that similar flood stories reflect universal human responses to any catastrophic flood experience and do not require a shared origin event. Others argue that the specific geographic details in certain traditions go beyond what that explanation alone can account for. Others emphasize that apparent similarities often conceal significant differences in detail and meaning when examined closely. This story will not pretend to resolve that debate. It will follow specific lines of evidence. Hold them honestly against what that evidence actually established. And resist the temptation to connect dots the evidence has not yet connected. One piece of evidence is specific enough and rigorously documented enough to deserve careful attention before we go further. In 2016, Patrick Nunn and Nicholas Reid, researchers at the University of the Sunshine Coast in Australia, published a study in the Journal of Geological Research examining 21 distinct oral traditions from Aboriginal Australian communities around the coastline of the continent. These traditions describe specific geographic changes to specific coastlines, bays that had once been dry valleys, islands that had once been hilltops surrounded by dry land, inlets that had once been rivers running through forest. Nunn and Reid cross-referenced these oral descriptions against the known geological record of postglacial sea level change along those specific Australian coastlines. The correlation was striking. The traditions were not vague, stories about water and catastrophe. In many cases, they were accurate descriptions of specific geographic transformations that had occurred between 7,000 and 13,000 years ago. Based on the rate of sea level change and the specific features described, the researchers estimated when the events being remembered had occurred. Their estimates ranged from approximately 7,000 to 13,000 years before the present. That is a significant span of preserved geographic memory, verified by independent geological analysis. Two careful statements about what this finding does and does not establish. What it establishes is that oral tradition, under the right conditions, can preserve accurate geographic information across timescales far longer than most scholars had previously considered plausible. It changes the evidential category of at least some flood stories, from stories about human psychology to stories that may also be about human geography. Stories worth checking against the physical record in their specific regional contexts. What it does not establish is that every flood story, in every culture, is a direct memory of the post-glacial sea level rise. Each tradition requires its own investigation in its own geographic context. The Aboriginal Australian finding opens the door. It does not walk through that door on behalf of every other tradition in every other part of the world. With that foundation in place, one more piece of this first chapter belongs here, 12,000 years ago, in what is now southeastern Turkey. People built something that the standard model of human prehistory did not predict. The site is called Göbekli Tepe, It was excavated beginning in 1994 by the archaeologist Klaus Schmidt of the German Archaeological Institute, who recognized that the stone formations visible at the surface were not the medieval cemetery a previous survey had recorded them as. What he found beneath required decades of work to begin to understand. Göbekli Tepe is a complex of large circular enclosures, each lined with T-shaped limestone pillars up to 6 meters tall, carved with detailed reliefs of animals and symbols. The construction required cutting and moving stones weighing between 10 and 20 tons. It required organized, sustained labor on a scale that the standard model of human prehistory in that period had not predicted for hunter-gatherer communities in that region. The carbon dating of Göbekli Tepe places its construction beginning at approximately 11,600 years ago, at almost precisely the moment when the postglacial sea level rise was entering its most disruptive phase, when coastal communities around the world were losing the landscapes they had inhabited for generations. Before his death in 2014, Klaus Schmidt said that Göbekli Tepe required a revision of the standard model of when human social complexity began. He did not claim it proved that refugees from a flooded coastal world had built it. The evidence does not support that specific claim. What he said was more measured, that the existence of Göbekli Tepe meant that human organizational capacity in that period was more sophisticated than the previous evidence had allowed scholars to assume. The previous evidence was gathered almost entirely from sites on land that had been above water since the last ice age. The sites that were below water since the last ice age have barely been investigated. That is where this story is going. Not to a conclusion already decided, to an investigation still underway. In the places where the ocean floor holds, whatever it holds, from the world that existed before the water rose. Chapter 2. The Greek Memory. There is a room in an Egyptian temple city, sometime around 600 years before the Common Era. The room is lit by oil lamps. The air smells of the Nile. An Athenian visitor named Solon, one of the most respected lawgivers of his world, is sitting with Egyptian priests who are showing him records they say are older than anything in the Greek tradition. We do not have those records. We do not have Solon's notes from that night, if he took any. What we have, too, is a story that Solon apparently brought back to Athens, passed through his family across generations, and eventually reached a man named Plato, who wrote it down around 360 years before the Common Era and placed it in the mouth of a character named Critias. The story described a powerful civilization beyond the Pillars of Hercules, the strait we know today as Gibraltar. It had attempted to conquer the Mediterranean world. It had been defeated, and then, in a catastrophic event, it had gone beneath the sea. Plato called it Atlantis. For more than 2,000 years, that name has accumulated so many layers of argument and wishful thinking and deliberate misrepresentation that engaging with it honestly requires setting aside almost everything attached to it and returning to the actual text. Tonight, we are going to do exactly that. Not ask whether Atlantis existed, as Plato described it. That question has not been answered and may never be. Ask instead what the specific details Plato recorded can tell us about where the story came from, and how those details sit alongside what we now know about the geophysical conditions at the end of the last ice age. Begin with something the Atlantis debate has not always given sufficient weight. Plato understood clearly the difference between a myth constructed for philosophical purposes and a historical account presented as factual. When he wrote allegory, he signaled it. The allegory of the cave is not framed as history. The myth of is explicitly introduced as a story. The Atlantis account is framed differently. The character presenting it explicitly distinguishes it from invented myth. He says Solon verified the account as historical. He says the Egyptian priests emphasized that Greek memory reached back only a few centuries, while their records went back much further and preserved events the Greeks had entirely forgotten. Whether this framing reflects a genuine source chain or is itself part of Plato's literary construction is a question that classical scholars have debated seriously for generations. The honest answer is that we do not know. But the framing is not the framing Plato used when he was constructing allegory. And that asymmetry is worth noting. Now consider the specific details the account contains. Plato gives a date for the destruction of the civilization. 9,000 years before Solon's visit to Egypt. Solon visited Egypt at around 600 years before the Common Era. 9,000 years before that places the event at approximately 11,600 years ago. This coincidence with the period of maximum coastal disruption at the end of the last ice age has been noted by researchers on multiple sides of the debate. Before assigning it any meaning, three possibilities deserve genuinely equal weight. The first is that the number reflects a real ancient memory of coastal catastrophe at the end of the Ice Age, transmitted through Egyptian records based on still earlier sources. The second, equally plausible, is that it is coincidence, a large round number expressing mythological antiquity that happens to land near a real geophysical event. The third is that Plato adjusted the number for the philosophical and narrative purposes of his dialogues, and any resemblance to the Ice Age timeline is incidental. The evidence cannot determine which is correct. A researcher inclined toward credibility will emphasize the first. A researcher inclined toward skepticism will emphasize the second or third. The honest position holds all three open, with no thumb on the scale. The geographic details Plato provides raise similarly open questions. He describes the civilization as located in the Atlantic beyond Gibraltar, with a circular city built on concentric rings of land and water connected by canals to the sea. He gives specific measurements for agricultural plains and canal systems. He mentions specific metals with specific locations. The level of detail is not characteristic of Plato's allegorical writing, where details serve philosophical argument rather than geographic description. The classical scholar Pierre Vidal-Naquet, one of the most rigorous academic critics of Atlantis theories in the 20th century, argued carefully that the account was most likely Plato's own philosophical invention. His analysis is serious scholarship, and his conclusion deserves genuine respect. Even Vidal-Naquet acknowledged that Plato was drawing on material with some external origin, and that the question of what Solon encountered in Egypt was one the surviving evidence could not definitively resolve. The honest position is the same one reached from both skeptical and open directions. The origin of the account is genuinely uncertain. It may be invention. It may be tradition. It may be both. Mixed in proportions, we cannot now determine. One geographic observation belongs here. Stated carefully. When ancient writers referred to the Atlantic beyond Gibraltar, they often meant specifically the shallow coastal waters just west of the strait, the continental shelf areas of what is now the western coast of Europe and northwestern Africa. Those shelf areas were, at the height of the last ice age, exposed land. They are now underwater at depths accessible to modern underwater archaeology. Whether the Atlantis account is pointing, imprecisely and through many layers of transmission, at those real drowned shelf areas, or whether it is pointing at nothing geographically real, is a question the account alone cannot answer. It is a question that systematic surveys of those shelf areas could begin to approach. Those surveys have not yet been conducted. Now, step back from Plato and look at the broader Greek tradition. The flood of Deucalion is one of the oldest stories in Greek mythology. Zeus sent a great flood. Deucalion survived and became the ancestor of a renewed human race. The structural parallel to Mesopotamian and Hebrew flood narratives is well documented. What is less often examined is how ancient Greek scholars themselves situated this story in relation to real geography. The geographer, Strabo, writing in the 1st century before the Common Era, discussed ancient accounts of dramatic geographic changes in the eastern Mediterranean, including land that had been submerged and coastlines that had shifted. Strabo was a careful thinker who did not accept every ancient account uncritically, but he took seriously the possibility that some traditions preserved genuine geographic memory. He treated certain flood accounts not as obvious myth, but as geographic reports worth examining against the observable landscape. His treatment does not confirm that Greek flood traditions are memories of the post-glacial sea level rise. It confirms that serious ancient writers treated some flood traditions as potential geographic evidence. That is a more modest claim, and it is the defensible one. One more ancient source deserves mention. Briefly, and with appropriate caution, Diodorus Siculus, a Greek historian of the 1st century before the Common Era, described a large, fertile island in the Atlantic known to Phoenician sailors as a commercial secret. This passage has been cited alongside Plato as independent corroboration. The caution needed is significant. Diodorus was writing 3 centuries after Plato. His source for this passage is unknown. It may describe a real Atlantic island the Phoenicians knew. It may describe something else entirely. It cannot bear the weight of independent corroboration. It is a piece of the puzzle worth noting without drawing conclusions from it. The Greek tradition contains stories of drowned worlds and civilizations lost to the sea, framed in ways their ancient authors distinguished from pure invention, with specific details that raise questions the texts alone cannot answer. What those traditions are evidence of, and in what sense, is a question that points outward from the texts toward the seafloor in the regions they describe. And that seafloor, in the shallow shelf waters west of Gibraltar, where ancient coastal land went under the sea at the end of the Ice Age, has not yet been asked what it holds. Chapter 3. The Sanskrit Memory. In the summer of 2001, a researcher named S.N. Rajagopalan was sitting in a laboratory in Chennai, looking at acoustic data from a survey of the Gulf of Khambhat, and trying to understand what he was seeing. The sonar images showed geometric patterns on the seafloor at a depth of approximately 40 meters. Regular shapes, right angles, the kind of patterns that experienced researchers know to examine carefully. Because geology can produce regular features that look structural, and because sometimes the patterns really are structural, the National Institute of Ocean Technology sent additional equipment. Sediment samples were collected and sent for carbon dating. The organic material returned dates, suggesting an age of approximately 9,500 years. The findings were published. The scientific debate began immediately. Researchers who examined the data critically raised serious objections. The carbon dating of organic material does not necessarily connect that material to whatever structural features may be present. Geometric patterns in sonar data can result from natural geological processes, including rock fracturing along regular plains, sediment movement by currents, and other processes that produce regular shapes without human involvement. Critics argued that the distinction between natural formation and human construction had not been established to their satisfaction from the available evidence. The debate has continued ever since. As of the time this story is being told, the Gulf of Khambhat site remains genuinely unresolved, not confirmed as an archaeological site, not definitively explained as a natural formation. An open question requiring further investigation before any conclusion can be drawn. That is its accurate status tonight. This story will not draw conclusions from it, but it will sit with the image for a moment, because the image matters regardless of what the debate eventually resolves. 40 meters below the surface of an Indian bay, something is there. Whether it is ancient human construction or a remarkable natural formation, it sits at a depth that was dry land 9,000 years ago, in a region whose coastal geography was fundamentally transformed by the rising Arabian Sea at the end of the last ice age. The investigation is not finished. Now move to a different kind of evidence from the same tradition. Because the Sanskrit case does not rest on Khambhat, and the evidence that does not depend on Khambhat is considerably stronger. The Mahabharata is one of the longest literary works ever composed, a foundational text of Hindu culture containing within its vast narrative the story of Dwarka Dwarka was the city of Krishna. Built on the western coast of India as the capital of the Yadava kingdom, it is described as a sophisticated coastal city of towers and wide streets and carefully designed harbors. And then, after the death of Krishna, the sea took it. The ocean advanced and covered Dwarka. The survivors watched from higher ground as the water rose over the walls and the streets and everything they had known. In 1983, the Marine Archaeology Center of India, led by the oceanographer S.R. Rao, began underwater surveys in the Bay of Dwarka off the coast of the modern city of Dwarka in Gujarat state. What the team found on the seafloor were structural remains, stone walls, building foundations, stone anchors, artifacts including pottery and seals. The artifacts were dated to between 1500 and 3,500 years before the Common Era. The underwater ruins of Dwarka are not in dispute. The Archaeological Survey of India has accepted their existence. The structures are there. Two qualifications are necessary. The first is about dates. The dated artifacts place the settlement in the known historical period, not in the Ice Age period. This story is primarily examining whether there is an older layer of occupation beneath the known remains that corresponds to the earlier period of coastal transformation is a question the investigations conducted so far cannot answer. It may exist. It may not. The evidence speaks to a historical period settlement, and nothing yet speaks definitively beyond that. The second is about what the confirmation means. The Sanskrit tradition preserved the memory of a real coastal settlement that the sea eventually reached. The tradition was not inventing a city for philosophical purposes. It was remembering one. That capacity for preserving geographic memory of drowned coastal places is the significant finding here. Independent of whatever else Dwarka may eventually reveal. Now move further back in the Sanskrit tradition, to a geographic detail that became scientifically significant in a way no one in the 19th century could have predicted. Imagine a researcher, in the late 1990s, working with the first detailed satellite imagery of the Thar Desert in northwestern India and Pakistan. She is looking at the surface of one of the driest landscapes in Asia, and she is seeing something that should not be there. Beneath the desert surface, visible as a pattern of dried channels in the satellite data, is the unmistakable trace of a large river system, not a small seasonal watercourse, a major river, fed by tributaries from the Himalayas, flowing for hundreds of kilometers across what is now desert and out to the sea. A river large enough, and long enough, and real enough to have supported the civilization that grew along its banks. The river is the Saraswati. The Rig Veda, among the oldest religious texts in continuous use anywhere in the world, described it in detail. The river flowed from the mountains to the sea. It was bordered by cities and abundance. It was described with the specificity of a feature the composers of the hymns knew directly. The Saraswati does not exist today, but the satellite imagery showed that it had existed. Geological evidence suggests it dried up as a result of tectonic changes that diverted its Himalayan tributaries into other river systems, most likely between 4,000 and 3,500 years ago. The civilization that had flourished along its banks, known today as the Harappan or Indus Valley Civilization, was one of the largest urban cultures of the ancient world. The Sanskrit tradition had preserved an accurate description of a geographic reality. Independent scientific evidence confirmed it thousands of years later. This is the same mechanism documented by Nunn and Reid in Aboriginal Australia. Memory-specific and stable enough to be verified against independent scientific evidence across timescales of thousands of years. The Saraswati case does not prove that every geographic claim in Sanskrit literature is accurate. It demonstrates that the tradition has shown this capacity for geographic preservation in at least one independently verifiable instance. That is a meaningful data point about what the tradition is capable of. The flood narrative of the Sanskrit tradition centers on a figure named Manu. A divine fish warned Manu that a great flood was coming. He built a boat. He survived while the world was submerged. When the waters receded, his boat came to rest on a high mountain in the north, the structural parallel to Noah, to Deucalion, and to Utnapishtim in the Gilgamesh epic is clear and has been discussed extensively. What is worth noting is the geographic directionality of the Sanskrit version. Survival moves northward and upward. The catastrophe comes from the south and the coasts. The world that is lost is warm, southern, and fertile. This directional pattern is consistent with what the sea level data shows happened to the coastal regions of the Indian subcontinent at the end of the Ice Age. Consistent with is not confirmed by. The pattern is interesting and worth noting. The physical surveys of the drowned continental shelf that would be needed to test it have not been conducted with systematic coverage. The Sanskrit tradition presents, when examined carefully, three distinct layers of evidential strength. The Saraswati River case is the strongest. Geographic memory verified independently by satellite imagery. The Dwarka case is solid in what it confirms. Real underwater structures near a traditionally remembered location. And honest about what it does not yet establish, which is a direct connection to the Ice Age period. The Combat case is genuinely unresolved and should not carry the weight of conclusions until the scientific community reaches a clearer determination. These are three distinct layers, with three distinct levels of reliability. Holding them separately rather than grouping them together as a single unified body of Sanskrit evidence is the honest approach. The weakest case earns nothing from the stronger ones. Each stands on its own evidence and its own current state of verification. What the Sanskrit tradition offers this investigation, taken on its own actual terms, is a documented instance of accurate geographic memory verified by independent science, a confirmed case of an underwater coastal settlement matching an oral tradition's description, and an unresolved underwater site whose investigation is ongoing. That is enough to take the tradition seriously as a potential source of geographic information. It is not yet enough to tell us what the sea floor of the Arabian Sea contains from the period before the sea rose. That question is waiting for the surveys that will eventually ask it properly. Chapter 4. The Mesopotamian Memory. There is a clay tablet in the collections of the Ashmolean Museum in Oxford that is approximately 4,000 years old. It was written by a Sumerian scribe who was copying from an older document, which was itself a copy of something older still. The scribe pressed wedge-shaped marks into wet clay with a Reid stylus. Marks that record a list of kings and the cities where they ruled, stretching back to a time the scribe understood as the beginning of civilization itself. The document is called the Sumerian King List, and it begins with a line that historians have been reading carefully since it was first translated in the early 20th century. After the kingship descended from heaven, the kingship was in Eridu. The King List records the names of 8 kings who ruled before a great flood. It records how long each of them reigned in units of time so vast that the pre-flood reigns run to tens of thousands of years each. Most scholars interpret these numbers as a way of expressing mythological antiquity rather than as literal historical records, and that interpretation is reasonable and probably correct. What matters for this story is not the numbers, but the structure and the geography. The King List reads like an administrative document. It is systematic. It lists names, cities, and durations in the same dry, methodical way that Sumerian scribes recorded grain inventories and property transfers. The flood it describes is presented not as metaphor or allegory but as a historical event, after which the kingship was swept away and then descended again to a new location and a new beginning. And every city named in the list before the flood sits in the lower reaches of Mesopotamia, on the flat alluvial plain between the Tigris and Euphrates rivers, where they approach what is now the northern end of the Persian Gulf. That geographic concentration is the entry point for a piece of research that introduced a new dimension to how some scholars think about the origins of Sumerian civilization. In 2010, Geoffrey Rose, a researcher affiliated with the University of Birmingham, published a paper in the journal Current Anthropology built around a simple but consequential observation about the Persian Gulf. The Persian Gulf is extraordinarily shallow. Its average depth is only about 35 meters. At the peak of the last ice age, when global sea levels were roughly 120 meters lower than today, the entire Persian Gulf basin was dry land, a river valley, fed by the Tigris and the Euphrates and the Karun and other rivers flowing down from the surrounding highlands, draining southward through a channel at what is now the Strait of Hormuz and out to the Arabian Sea. Rose examined the paleoclimate data for the region and argued that this valley, which he called the Persian Gulf Oasis, would have been among the most habitable environments in the ancient world during the Ice Age, a period when much of the surrounding landscape was arid and inhospitable. It had freshwater rivers. It had a mild climate, moderated by the surrounding highlands. It had the ecological conditions that support large, stable human populations. Then the ice melted. The sea rose. Rose estimated the Persian Gulf flooded between approximately 8,000 and 6,000 years before the Common Era, with the most rapid phase potentially occurring within a period short enough to be experienced as catastrophic within a few generations. In his published paper, Rose proposed that this displacement, communities moving north out of a flooding valley into the Mesopotamian plain above it, may have provided the population concentration and cultural catalyst that contributed to the rapid emergence of complex societies in Mesopotamia in the subsequent centuries. This is a hypothesis. Rose presented it as a hypothesis, grounded in geophysical data, designed to be tested rather than accepted. It has been discussed since its publication. It has not been confirmed. The seafloor of the Persian Gulf has not been surveyed with the systematic coverage needed to test it directly. It sits where it has sat since 2010, an interesting and geophysically grounded possibility, waiting for the investigation that would either support or challenge it. Now, bring in the text most people already know, because the Gilgamesh epic deserves to be read in the context this chapter is building. The Epic of Gilgamesh tells the story of a king of Uruk who seeks immortality and eventually finds Utnapishtim, the one man who survived the Great Flood. Utnapishtim tells the story of how the god Ea warned him in a dream, how he built a boat of specific dimensions and loaded it with the seed of all living things, how the flood lasted 6 days and 7 nights, how his boat came to rest on a mountain, and how he sent out birds to find dry land. Utnapishtim identifies himself as a citizen of Shuruppak. Shuruppak is a real city. It has been excavated. Its lower levels contain a layer of water-deposited silt that excavators identified as evidence of a real flood event. Leonard Woolley, excavating the ancient city of in the 1920s, found a similar silt layer approximately 2.5 meters thick. He described it initially as evidence of the biblical flood, a characterization that subsequent analysis complicated. The silt layers at and Shuruppak do not date to the same period, meaning they do not straightforwardly confirm each other. 2. What they do confirm is that significant flood events left physical traces in the archaeological record of Lower Mesopotamia across different periods. The people who wrote the Gilgamesh epic were not inventing flood catastrophe as a narrative convenience. They were living in a landscape where it had happened, and where the physical evidence was in the ground beneath their cities. The Gilgamesh flood narrative is almost certainly carrying multiple layers of memory simultaneously. The memory of recurring local flood events in Lower Mesopotamia, possibly the memory of a more ancient and more total flooding of the Persian Gulf Valley, possibly theological meanings accumulated across centuries of transmission. Separating these layers precisely is a task the text alone cannot accomplish. Eridu, the city, the king list names as the first, is the oldest in the Mesopotamian archaeological record. Excavations at Eridu revealed a small mud brick temple at the lowest level, the first building on that ground, that was rebuilt and expanded 18 times on the same spot over the millennia. 18 temples on the same ground across thousands of years. Whatever happened at Eridu in its earliest period was important enough that generations of people kept returning to honor the same place. Whether that sanctity reflects a memory of people who came from a flooded homeland to the south and built their first sacred space in a new land is a possibility the evidence raises without confirming. It is worth holding as a possibility. It is not worth asserting as more than that. The Mesopotamian case for this investigation rests primarily on Jeffrey Rose's geophysical hypothesis, the most scientifically grounded specific claim in this part of the story, and on the Gilgamesh epic, the oldest written flood narrative in the world, which locates its survivor in a real city, in a real landscape, directly above the region Rose identified. Those two things together, the geophysical case for a habitable drowned valley and the oldest written flood memory, placing its central figure in the region directly above that valley, constitute a genuine and interesting convergence that points toward a specific body of water and a specific set of questions the seafloor of that body of water could eventually help answer. Not proof. Convergence. The distinction is real, and this story will maintain it. The surveys of the Persian Gulf floor that would begin to test Rose's hypothesis directly are in their early stages. The questions those surveys are asking have never been asked before with instruments adequate to the task. What the answers will be, we do not yet know. But the clay tablet in the Ashmolean, pressed 4,000 years ago by a scribe copying something older still, has been pointing toward those questions for a very long time. Chapter 5. The Pacific Memory. There is a moment that Vincent Gaffney, the archaeologist who led the Europe's Lost Frontiers project, has described in interviews as the one that changed how he thought about the scale of what had been lost. He was sitting in a laboratory at the University of Bradford, looking at processed sonar data from the southern North Sea, and watching a map take shape on his screen that no living person had ever seen before. It was not a map of the ocean floor as it exists today. It was a reconstruction, derived from high-resolution seismic survey data, of the floor of a landscape that had been above water 8,000 years ago and had been submerged ever since. As the data rendered, he could see river channels, ancient lake basins, the elevated ground where communities would have built their settlements above the flood plains of rivers that no longer existed anywhere except in this data. In the geometry of sediment layers, on the floor of a cold northern sea, he was looking at a world that had been home to people, that had been mapped in the memories of those people, that had gone under the water so completely that until the oil industry spent decades drilling and scanning the North Sea floor in search of hydrocarbons, nobody had known it was there. That world is called Doggerland. And it is the confirmed, documented, rigorously investigated anchor case for everything this story has been building toward. The physical proof that the coastal worlds described in the traditions of a dozen cultures were not myth but geography, and that those geographies are waiting, in varying states of preservation, beneath the shallow seas of the world. But before we return to Doggerland, this chapter belongs to a different ocean. The Pacific is the largest geographic feature on the surface of the Earth. It covers more area than all the land on the planet combined. Its islands, scattered across millions of square kilometers of open water, are home to some of the most diverse human cultures ever documented. Cultures that preserve their histories in oral traditions of extraordinary richness and precision. And across that ocean, from the islands of Southeast Asia to the furthest reaches of Polynesia to the Aboriginal communities of the Australian coast, the oldest stories share something that researchers have begun to take seriously as more than coincidence. They remember a world that is under the water. Not the same world, not the same event, not all with the same geographic specificity or the same level of verifiable detail. What they share is the experience of a world that was once larger and is now smaller. A world, the sea reduced, and the knowledge that what the sea took is somewhere beneath the surface. Not gone, but unreachable. Begin with the geology. Because the geology is the non-negotiable foundation. At the height of the last ice age, the shallow continental shelf of Southeast Asia was dry land. Geologists call this drowned landmass Sundaland. It extended from the Asian mainland across what is now the South China Sea and the Java Sea, connecting the modern islands of Sumatra, Java, Borneo, and Bali to each other and to the mainland in a single landmass roughly the size of modern India. Sundaland was not marginal land. The climate of the region during the Ice Age was cooler and drier than today, but still tropical. Its rivers created extensive lowland plains and estuaries of high ecological productivity. By every measure, researchers have applied to its reconstructed geography. Sundaland was one of the most favorable environments for human habitation in the ancient world. When the ice melted and the sea rose, Sundaland flooded. The flooding occurred over thousands of years, punctuated by the same meltwater pulses that affected every other coastline. The geography of Sundaland made it particularly vulnerable because so much of its area was low-lying coastal plain. A rise of 10 meters in sea level did not simply move the shoreline back a few kilometers. It converted vast areas of inhabited lowland into shallow tropical sea within timescales, visible within human generations. By approximately 8,000 years ago, the flooding of Sundaland was essentially complete. The modern islands of Southeast Asia are what remains above water. They are the mountain peaks and ridgelines of a drowned world. The only parts that the sea did not take. The people who had lived in Sundaland moved. They moved to the islands that remained. They moved in boats to new coasts. They spread outward across the Pacific in one of the great migrations of human prehistory. The linguistic evidence for this migration is extensive. The Austronesian language family, which includes languages spoken from Madagascar in the west to Easter Island in the east and from Taiwan in the north to New Zealand in the south, represents one of the most widely distributed language groups in human history. Historical linguists place the origin of Austronesian expansion in Taiwan approximately 6,000 years ago, spreading southward and outward in waves of migration that eventually reached virtually every habitable island in the Pacific. The navigational traditions of the people who made these migrations were extraordinary. They crossed thousands of kilometers of open ocean using the stars, the currents, the swell patterns beneath their boats, and knowledge systems refined across generations. A Polynesian navigator in the open Pacific, far from any land, could determine position and direction from the way the ocean moved beneath the hull of a vessel in the dark, from patterns of wave reflection, off islands, hundreds of kilometers away, from the behavior of birds and the color of water. This was not improvised skill. It was the inheritance of a maritime culture with a heritage far older than the known record of Austronesian expansion. Rooted in the long occupation of the coastal environments of Sundaland, the oral traditions of Austronesian cultures across the Pacific preserve, in their oldest layers, references to a homeland that was larger and more extensive than the islands their people now inhabit. These references vary significantly between cultures. They are not all saying the same thing. In some traditions, the homeland is described as a specific large landmass. In others, it is a more abstract place of origin. In others, the memory of departure across water is more vivid than any description of the place departed from. Treating all of these as a single uniform body of evidence, pointing to a single conclusion, would misrepresent what the traditions actually contain. They share an orientation rather than a description, an awareness that the ancestors came from somewhere now inaccessible. Whether that orientation reflects a direct geographic memory of Sundaland, or the more general experience of any migration by sea, or cosmological beliefs about the direction of origins that are not primarily geographic, is a question that has not been resolved by careful research. The strongest specific piece of evidence for Pacific oral traditions preserving accurate geographic memory of the postglacial sea level rise remains the Aboriginal Australian case documented by Nunn and Reid. Their methodology, cross-referencing specific oral descriptions against specific geological records of specific coastlines, has not yet been applied with equivalent rigor to the coastal traditions of Southeast Asian, Austronesian communities. Some preliminary work in this direction has been published by researchers following the Nunn and Reid approach, with suggestive results that make the investigation worth pursuing. But the research is not yet at the stage where conclusions comparable to the Australian case can be drawn with confidence. Now, come to the Polynesian tradition and what it can and cannot tell us. Across virtually all Polynesian cultures, the oldest cosmological and genealogical traditions preserve a concept of an ancestral homeland called Hawaii. Hawaii is not the modern island of Hawaii, though the names share a linguistic root. It is the origin place, the direction from which the first ancestors came, the source of the Polynesian peoples. Different Polynesian island traditions place Hawaii in different directions, which scholars have noted as a complication for any interpretation of Hawaii as a single specific geographic location. The scholarly consensus treats it primarily as a cultural origin concept, a symbolic homeland, rather than a map coordinate. That consensus is reasonable given the current evidence. The question of whether any kernel of specific geographic memory underlies the symbolic concept has not been investigated with the tools that could potentially test it. It remains genuinely open, in the sense that the evidence neither confirms nor rules out a geographic dimension to the Hawaii tradition. What the Polynesian navigational tradition does establish, independent of questions about Hawaii, is a maritime heritage of extraordinary depth. The capacity to cross thousands of kilometers of open ocean using traditional methods is not a skill that appears without a long history behind it. That history was forged in the coastal environments of Southeast Asia across timescales that the conventional timeline of Polynesian expansion does not fully account for. There is one element of the Pacific memory that this chapter needs to address directly, because it has caused significant confusion. The names Lemuria and Mu refer to invented traditions with no scientific foundation. Lemuria was created in the 19th century to explain fossil distributions and later adopted by occult writers. Mu was invented outright by a non-scholar in the early 20th century. Neither has any relationship to the actual evidence from the Pacific. Both have been attached to discussions of Sundaland in ways that contaminate genuinely interesting questions with material that deserves no scientific consideration. This story has no interest in either of them. The genuine evidence from the Pacific is significant on its own terms. The flooding of Sundaland is confirmed geology. The people who lived there before it flooded were real. Their descendants carry the genetic and linguistic and cultural inheritance of that displacement. Whether their oral traditions preserved specific geographic memories of the lost landscape, and whether the seafloor of the South China Sea and the Java Sea contains the physical evidence of the human occupation that Sundaland once supported, are questions that the methodology demonstrated by Nunn and Reid could begin to test, and that sonar surveys of the region could begin to approach. Neither investigation has been done comprehensively. Both are worth doing. Vincent Gaffney looked at his screen in Bradford and saw a world that nobody had seen for 8,000 years. He saw it not because he expected to find something extraordinary, but because he and his team were willing to ask the seafloor a question that nobody had thought to ask before with the right instruments. Somewhere in the South China Sea and the Java Sea, below the water and the sediment and the 8,000 years of silence, the landscape of Sundaland is still there. Not gone, waiting for the researcher who will sit down one day at a screen in a laboratory somewhere, look at the data coming back from the seafloor, and begin to see the rivers and the coastlines and the world that the Pacific's oldest stories have been pointing toward all along. Chapter 6. The Man Who Looked at the Seafloor. There is a photograph taken in 1997 of a man standing on a beach in Tenerife, one of the Canary Islands, at the edge of the Atlantic Ocean. He is looking at the water, not at the horizon, at the water itself, at the point where the waves meet the sand and then retreat, the exact line where land becomes sea. He has just finished diving on a submerged site off the island's coast, a site where ancient structures lie in shallow water. visible through a dive mask, tangible and real, and not yet explained to anyone's full satisfaction. The man's name is Graham Hancock. He is 47 years old. He is a former foreign correspondent for The Economist, who has spent the past several years traveling to underwater sites around the world, talking to researchers who are largely ignored by the mainstream of their profession, and building an argument that the standard timeline of human civilization is wrong in a specific and important way. The argument is not that a magical advanced civilization left behind pyramids and psychic knowledge. The argument is simpler and more defensible than that. It is that the most densely inhabited environments of the ancient world were coastal lowlands, and those coastal lowlands are now underwater. And the profession of archaeology has spent the last century building its understanding of the human past almost entirely from evidence gathered above the waterline. And that this is a problem. That argument is correct. What Hancock did with it, and what professional researchers did with the same underlying observation, and why those two paths diverged so significantly, is the subject of this chapter. Begin with what he identified correctly, because the list is real and deserves acknowledgement. He was correct that the standard archaeological timeline was built almost entirely on evidence from sites above the postglacial sea level. He was correct that this was a significant methodological limitation, because the coastal lowlands, now underwater, were precisely the environments most likely to have supported large, stably human populations. He was correct that underwater archaeology was severely underfunded relative to its importance. He was correct that the end of the last ice age involved catastrophic disruption of coastal environments worldwide, and that the archaeological record of that period was genuinely and substantially incomplete. These observations were not original to Hancock. They were observations that researchers in geology, physical geography, and underwater archaeology had been making in specialist publications for years before his books brought them to a vastly larger audience. But the audience mattered. The questions needed to be asked publicly as well as professionally. And Hancock asked them publicly in a way that the researchers working within academic constraints had not done. Jeffrey Rose, whose Persian Gulf Oasis hypothesis this story examined in the previous chapter, arrives at conclusions broadly consistent with some of what Hancock argued. Specifically, that significant human populations lived in coastal environments, now underwater, and that the flooding of those environments contributed to the dynamics of early civilization. Rose arrived at his conclusions through peer-reviewed research with careful qualification of claims. Hancock arrived at similar geographic intuitions through a journalistic process that did not always maintain those qualifications. That difference matters. Not because academic credentialing determines truth, but because the discipline of distinguishing what the evidence shows from what the investigator hopes to find is what allows knowledge to accumulate rather than simply assert itself. Now, consider what Hancock has not proven. His central claim, that a sophisticated global civilization existed before the end of the last ice age and was destroyed by a cosmic impact at approximately 12,900 years ago, goes significantly beyond what the current evidence supports. The Younger Dryas impact hypothesis, which proposes that a comet or asteroid struck the Earth at approximately that time and triggered a period of rapid climate cooling, is a genuine scientific hypothesis with genuine scientific supporters. It has been published in peer-reviewed journals. It has also been challenged by researchers who dispute the interpretation of the physical evidence cited in its support. As of the time this story is being told, the debate continues. It is an open scientific question, not a settled one. The connection Hancock draws between this hypothesis and a specific lost civilization of global sophistication requires physical evidence that has not been produced. The absence of that evidence does not prove that communities of some kind did not exist in coastal environments now underwater. Absence of evidence in an uninvestigated domain is not evidence of absence, but it does mean the specific claim cannot be treated as established. Now consider something that popular discussions of Hancock often miss. Many of the researchers who are doing the most important work on drowned prehistoric landscapes arrived at their questions independently, through their own professional trajectories. With no relationship to the popular debate Hancock was conducting in parallel, Nick Fleming was documenting submerged prehistoric sites around the coasts of Europe and the Mediterranean years before Hancock's first major book on the subject. His estimates of more than 2,000 documented but unexcavated submerged prehistoric sites around European coastlines alone were based on decades of field research and site documentation, conducted within the institutional frameworks of marine geology and underwater archaeology. Glenn Milne's geophysical modeling work, which this chapter will examine in detail, was driven by questions in glaciology and solid Earth physics. The fact that his sea-level reconstruction models had profound implications for where ancient coastal populations had lived was a consequence of his research, not its motivation. Vincent Gaffney's Europe's Lost Frontiers project was funded through mainstream academic channels and conducted by a team of geophysicists, archaeologists, and geographers who were asking questions about European prehistory, not about lost civilizations. The field of underwater prehistoric archaeology exists and is growing because of the accumulated work of these researchers and others like them. The suggestion that it exists primarily because Hancock asked an uncomfortable question that the Academy was too rigid to ask overstates his role and understates the independent scientific trajectory that was already underway. This is not a dismissal of his contribution to the public conversation. It is an accurate description of where the actual research came from. Now turn to Glenn Milne, because his work is foundational to everything in the remaining chapters of this story and is often overlooked in discussions dominated by the popular debate. Glenn Milne is a geophysicist who has spent his career studying how sea levels change over time and what drives those changes. Working at the University of Durham and subsequently at the University of Ottawa, Milne and his collaborators developed a computational model that reconstructs the position of ancient coastlines at any point in the past. Based on known data about ice sheet volume and the gravitational and isostatic effects of ice sheet changes on sea levels around the world, picture him at a workstation sometime in the mid-1990s, running calculations that no one had run before at this resolution. The model takes as input what is known about the volume and distribution of the ice sheets at any given point in the past. It accounts for the gravitational pull of the ice itself on the surrounding ocean, for the depression of the land beneath the ice weight, for the ongoing slow rebound of that land as the ice retreats. It produces as output a map of where the ocean surface was at any given moment in the past, for any location on Earth. The maps the model produces are not artistic reconstructions. They are the output of geophysical calculations based on well-established physical principles and extensive empirical data from ice cores, ocean sediment records, and coral reef formations that serve as sea level benchmarks around the world. They have been published in leading scientific journals and used by mainstream researchers in geology, archaeology, and climate science. What those maps show is what this story has been describing throughout. At the peak of the last ice age, vast areas of shallow continental shelf were exposed as dry land. As the ice melted, those areas flooded at rates that varied by region and period. The specific geography of every drowned prehistoric coastline can be reconstructed for any point in time. Using Milne's modeling approach, the significance of this for underwater prehistoric archaeology is precise and practical. If you know where the coastline was 10,000 years ago, and the model can tell you that, you know where the most densely inhabited land of that period is most likely to have been. And if you know where that land is now, which the model can also calculate, you know where on the seafloor to direct your surveys. This tool exists. It is being used. It has not been applied systematically to anything approaching the full extent of the areas where it could productively guide investigation. That is the gap between what is technically possible and what has actually been done. It is a gap driven by funding and logistics and institutional inertia, not by any fundamental scientific obstacle. The obstacle is not the tools. The obstacle is the will and the resources to use them at the scale the question demands. That scale is large. The drowned prehistoric coastlines of the world cover an area that dwarfs any archaeological project ever undertaken. It will not be investigated in a decade. It will require generations of researchers, sustained institutional commitment, and international coordination that does not yet exist at the required level. But the investigation has begun. In the North Sea and in the Persian Gulf and in the waters around the Indian subcontinent and in the shallow seas of Southeast Asia, researchers, with the right tools and the right questions, are beginning to ask the seafloor what it holds. What it holds is the subject of the chapter that follows. Chapter 7. What the Seafloor is Saying. Return to Vincent Gaffney in his laboratory in Bradford. The year is 2017. The Europe's Lost Frontiers project is in its second year. His team has been processing high-resolution seismic survey data from the southern North Sea. Data originally collected by the oil and gas industry in its search for hydrocarbons beneath the seafloor. Repurposed. Now for a question the oil companies never thought to ask. On his screen, slowly rendering as the computational processing completes, is a landscape. Ancient river channels cutting across a broad plain. The basins of lakes that filled and drained across thousands of years as the climate shifted. Elevated ground where communities would have built their settlements above the floodplains below. A world in such geographic detail that Gaffney can see where the rivers forked and where the lakes narrowed and where the higher ground offered the kind of sheltered, elevated positions that ancient communities sought when they chose where to build. The last human being who stood in this landscape stood there approximately 8,000 years ago, before the North Sea finished filling and closed over everything. Gaffney is looking at Doggerland. Doggerland is the anchor case for everything this story has been building toward. Not a hypothesis, not an interpretation. Confirmed, rigorously documented, peer-reviewed archaeological reality. A landscape that occupied what is now the southern North Sea, connecting the British Isles to continental Europe across an area of rivers, lakes, marshes, and rolling hills. That was, by every ecological measure available to researchers who have studied it, one of the most productive environments in postglacial Europe. Its existence was not suspected until fishermen began hauling up mammoth bones and stone tools in their nets over the Dogger Bank in the early 20th century. Its scale was not understood until Brian E. Coles of the University of Exeter coined the name and began synthesizing the scattered trawler finds and geological surveys in the 1990s. Its geography was not mapped in detail until Gaffney's project processed the oil industry's seismic data and rendered the world that the data contained. The flooding of Doggerland occurred over thousands of years as the ice sheets continued to melt. The process ended dramatically around 8,200 years ago when a massive underwater landslide off the coast of Norway, known as the Storge Slide, generated a tsunami that swept across the low-lying plains of Doggerland. Researchers studying sediment cores from the North Sea floor have found the physical trace of this event at multiple locations. A distinct layer of tsunami-deposited material dated precisely to that period. The evidence of the disaster is in the sediment. The people living in Doggerland at the time of the Storge tsunami and in the centuries of slower flooding that preceded it did not all perish. They moved. They retreated to the higher ground of what is now Britain to the west and the continental mainland to the east, carrying their tools and their knowledge and, in the memory of what they were leaving behind, the beginning of a story. Gaffney's project demonstrated something that extends far beyond Doggerland itself. It demonstrated that the technology to reconstruct ancient submerged landscapes in sufficient detail to identify and investigate archaeological sites within them already exists. That it can be applied using data collected for commercial purposes and repurposed for archaeological research. And that the results can be both methodologically rigorous and historically transformative. The same approach is, in principle, applicable to the submerged shelves of the Persian Gulf. the South China Sea, the Indian Ocean, and the Pacific. The knowledge that it could be applied there, demonstrated concretely by the Europe's Lost Frontiers project, is now available to the researchers and funding bodies who might direct the next generation of surveys. Now, move from the North Sea to the Pacific. Because Doggerland is not the only place where the seafloor has been yielding unexpected information. Off the southern coast of the Japanese island of Yonaguni, at depths between 5 and 27 meters, there is a rock formation that has been the subject of genuine scientific debate since its discovery by a diving instructor named Kihachiro Aratake in 1986. The Yonaguni Monument is a large formation approximately 250 meters long and 50 meters wide, with features that include flat terraces, right-angle corners, and what some observers describe as steps and ramps. The question at the center of the debate is whether these features result from natural geological processes or human construction. The geologist Robert Schoch of Boston University, who studied the structure through multiple diving expeditions, concluded that it is most likely a natural formation, a product of the tendency of the local sandstone to fracture along regular planes. These fracture patterns can produce right-angle features and flat surfaces without human involvement. And Schoch judged that the Yonaguni features were consistent with this natural process. Schoch is not a researcher who dismisses underwater anomalies reflexively. He is the geologist who argued, based on weathering evidence, that the Great Sphinx of Giza was considerably older than mainstream Egyptology accepted, a position that required taking on a well-established consensus. His conclusion about Yonaguni as probably natural carries weight precisely because it came from someone with no particular incentive to reach it. Masaaki Kimura, of the University of the Ryukyus, who also studied the structure extensively, argued that at least some features showed evidence of human modification. The debate between these positions has not been resolved. The Yonaguni Monument is a genuine geological puzzle whose origin remains uncertain. What is not in dispute is that the area was above sea level during the last ice age, and that the sea level data places its submergence at between 10,000 and 12,000 years ago. If any portion of the structure reflects human activity, that activity occurred in a terrestrial environment during the period this story has been examining. The evidence does not yet allow a determination either way. Now come to a finding that carries no such uncertainty, because its archaeological character is not in question and its significance for the relationship between oral tradition and physical evidence is direct. Off the coast of Mahabalipuram in Tamil Nadu, local fishing communities had described structures beneath the water near their coast for generations. The descriptions were specific. There were walls down there, they said. There were foundations. There were things that had been built for generations. The descriptions were noted and not acted upon. Then, in 2002, following reports that intensified after a brief exposure of the seafloor by the wave action of a storm, teams from the National Institute of Oceanography of India and from the Scientific Exploration Society in Britain conducted underwater surveys of the area. They found what the local traditions had described: stone walls, building foundations, artifacts consistent with human occupation, dated to between 1,500 and 3,000 years before the Common Era. The Mahabalipuram structures are not in dispute. They are there. The local oral tradition, pointing at a specific geographic location, described specific physical contents that were actually at that location. This is the same pattern documented by Nunn and Reid in Aboriginal Australia, operating over a shorter time scale. Oral tradition, preserving geographically specific information about what exists beneath the water at specific coastal locations. Information that survived long enough to be independently verified when someone finally directed instruments at the right place. The Mahabalipuram case cannot be used directly to validate claims about Ice Age geographic memory. The timescale is different, and the verification covers a different period. But it confirms that the mechanism is real. Coastal communities preserve accurate geographic information about specific underwater locations across multiple generations. The information can be precise enough to guide archaeological investigation. And when researchers finally look where the traditions point, they sometimes find exactly what the traditions described. That confirmation changes the weight we should give to other coastal traditions that are pointing at specific locations in specific directions along specific stretches of coastline. Not prove. Change the weight. The distinction is real and worth maintaining. The three findings this chapter has examined build toward a picture that is important to state precisely. Doggerland proves that drowned prehistoric landscapes of significant human occupation exist in the shallow seas of the world and can be systematically investigated with available technology. Yonaguni presents an unresolved question about a submerged structure in a region that was coastal during the relevant period. A question the current evidence cannot settle. Mahabalipuram confirms that coastal oral traditions can preserve accurate geographic information about specific underwater locations. Together, these establish the foundations of a research program, not the conclusions of one. The investigation is real, ongoing, and beginning to yield findings that the standard timeline of human prehistory could not have generated from land sites alone. The seafloor is not silent. It never was. Vincent Gaffney sat in his laboratory and watched a lost world render on his screen. He was not looking for a lost civilization. He was asking a geophysical question about a specific body of water using the best available data and the best available tools. And a world appeared. Chapter 8. The Question of Old Maps. There is a fragment of gazelle skin in the Topkapi Palace Museum in Istanbul. It is roughly 1/2 meter wide and 1 meter long. The surviving portion of a larger document that was made in 1513 of the Common Era. On it, in careful ink strokes, a man named Reid drew a map of the Atlantic Ocean as he understood it in the early 16th century. Reid was an Ottoman admiral and one of the most accomplished cartographers of his era. He understood the sea in the way that comes from spending a life on it. And he understood maps in the way that comes from studying every chart and document he could obtain. His other major work, the Kitab-ı-Bahriye, the Book of Navigation, is a systematic and detailed guide to the coasts and harbors of the Mediterranean and Aegean that demonstrates rigorous geographic methodology. He was not a man given to carelessness or invention. The map he made in 1513 shows the Atlantic with the western coasts of Europe and Africa on one side, and what appears to be the eastern coast of South America on the other. The accuracy of the South American coastline attracted scholarly attention when the map was first studied in 1929, because Columbus had reached the Caribbean only 21 years before the map was made. And the coast of South America was not yet comprehensively charted by European cartographers at that date. In the marginal notes written on the map, Reid explained his sources. He had compiled the map from a large number of charts and documents. He wrote, including maps drawn by Portuguese explorers of the southern Atlantic, a map associated with Christopher Columbus, and source maps that he described as dating from the time of Alexander the Great. Whether these specific claims about his ancient sources are accurate cannot be determined from the surviving evidence. Reid was a serious cartographer who worked systematically from multiple sources, and his explicit description of his methodology is the most direct evidence we have of where his geographic knowledge came from. Whether his characterization of certain sources as ancient was accurate, or whether it reflected imprecision about the age of documents that were old but not ancient, is a question we cannot resolve. The more widely discussed feature of the map is at its southern edge, below the recognizable Atlantic coastlines. The surviving fragment shows a landmass curving along the bottom of the map. This feature was identified by the historian Charles Hapgood of Keene State College in his 1966 book, Maps of the Ancient Sea Kings, as a depiction of Antarctica without its ice cover. The mainstream academic response to this claim is well-grounded and deserves to be stated clearly. European and classical geographers from antiquity through the Renaissance routinely included a large, speculative southern continent on their world maps. The concept of a terra australis incognita, an unknown southern land, was a standard feature of geographic theory for centuries before any southern continent was surveyed. Cartographers of Piri Reis's era included this theoretical landmass on their maps as a convention, based on geographic theory rather than actual knowledge. The geophysicist and historian of cartography John Olson conducted one of the most thorough analyses of Hapgood's specific claims and concluded that Hapgood had significantly overstated the correspondence between the map's bottom coastline and the actual subice topography of Antarctica. Olson's analysis is careful, and his criticisms are specific. His conclusion represents the current scholarly consensus on the subject, and this story accepts it as the more defensible interpretation. The Piri Reis map's southern landmass is most plausibly explained as the conventional theoretical southern continent of Renaissance cartography. Hapgood's claims about it went beyond what the evidence of the map supports. What remains genuinely interesting about the map, independent of the Antarctica question, is the documented chain of geographic knowledge that ran from the ancient Mediterranean world through the Islamic scholarly tradition to the Ottoman court of the early 16th century. The geographic tradition of the ancient world was extraordinary. Eratosthenes of Alexandria, in the 3rd century before the Common Era, calculated the circumference of the Earth with remarkable accuracy and produced a systematic description of the known world that drew on geographic reports assembled from across the Mediterranean and beyond. The geography of Claudius Ptolemy, compiled in Alexandria in the 2nd century of the Common Era, assigned mathematical coordinates to roughly 8,000 locations around the world and was the most systematic geographic reference work the ancient world produced. Ptolemy's geography was transmitted through Byzantine scholarship and arrived in Western Europe through a Latin translation in the early 15th century, where it had direct influence on the cartography of the Age of Exploration. The maps that guided European explorers in the 15th and 16th centuries were built, in significant part, on the mathematical framework that Ptolemy had established in Alexandria more than 1,000 years earlier. The transmission chain from Alexandria through the Islamic world to the Ottoman court was a real chain that carried real knowledge across centuries. How much of the geographic knowledge that was in the Alexandrian tradition at its height survived that chain of transmission? In what form, and with what accuracy, is a question that the history of cartography has not fully resolved. Piri Reis said he was drawing on ancient maps. That claim places his work, and the question of what geographic knowledge it carried, within a transmission chain whose beginning was in the greatest repository of geographic knowledge the ancient world produced. This is interesting. It raises real questions. It does not support the stronger claims that have been made about the Piri Reis map as evidence of a pre-Ice Age civilization with global geographic knowledge. Those claims go beyond what the map shows. The map shows that a serious 16th century cartographer believed he was working from ancient sources and produced a document with geographic accuracy in some regions that exceeded what contemporary European surveys alone would have predicted. That is interesting. It is not proof of the larger claims. The honest position is that the Piri Reis map is a remarkable document whose full source history we cannot recover, and whose most controversial interpretations are probably wrong. The question it raises about the survival of ancient geographic knowledge from Alexandria through the centuries is real. The answers to that question are not in the map itself. They are in the history of what the Alexandrian library held and how much of it survived. And that history is the one this story began with, in the empty shelves of the Serapeum and the questions they have been asking ever since. Chapter 9. The Architecture of Memory. Picture a beat in northern Australia. Sometime around 10,000 years ago, the coastline runs differently than it runs today. A bay that will one day be open water is now a valley, green and sheltered, with a river running through it to a shore that lies further west than any modern map would show. A community lives near this valley. They fish in it. They gather along its edges. They have names for its features, names that encode information about where the good fishing is, and where the fresh water runs, and where the ground is solid enough to build on. Then, the sea begins to come. Not in a single dramatic wave. In the slow, relentless, generation by generation, encroachment that characterized the postglacial sea level rise along this stretch of coastline. Within 2 or 3 generations, the valley is a bay. Within another generation, the bay is open water. The shore that the community fished from is now beneath the waves, visible on a clear day through shallow water, present but unreachable. Someone who grew up with that valley as a landmark, who learned its name as a child and learned what the name meant and where the good fishing was and where the fresh water ran, is now old. Their grandchildren have never seen the valley as land. They know it only as water, as the place that used to be something else, as the geography that exists in the stories of their grandparents. The old person tells the story. They tell it with the specific geographic details that make the story verifiable. The features of the landscape as it was, the direction it lay from the current shore, the way the river mouth looked before the sea took it. They tell it in the form that the tradition uses for information that needs to survive, not as casual reminiscence, but as the structured, rhythmically encoded, ceremonially reinforced transmission that the community has developed precisely for preserving the things that matter most. The grandchildren learn the story. They tell it to their children, 10,000 years later. 2 researchers at the University of the Sunshine Coast compare the specific geographic descriptions in 21 such stories against the geological record of sea level change along the specific Australian coastlines. The stories describe. The correspondence is striking. The stories are accurate. The valley that the first storyteller described is there in the sediment record, exactly where the stories said it was. Exactly as deep underwater as the sea level data predicts it would be at the date the tradition implies. This is not mystical. This is not coincidence. This is a memory system doing what it was designed to do. Understanding how that system works is essential to understanding what the flood stories from every coastal culture in this story actually represent and what they can and cannot tell us about the world the water took. Structured oral tradition is not casual retelling. It is a technology, a deliberately designed system for encoding, storing, and transmitting specific information across generations with a degree of fidelity that unstructured retelling cannot achieve and that modern observers who have not studied it closely tend to underestimate. The key mechanism is what memory researchers call the generation of multiple retrieval queues. Information stored in a single form is vulnerable to distortion because there is nothing to check a distorted version against. Information encoded simultaneously in multiple forms, as story and as song and as ceremony and as geographic description tied to specific landscape features, is far more resistant to distortion because any form that begins to drift can be corrected against the others. The Aboriginal Australian songlines are the most extensively studied example of this principle in operation. They are not metaphor. They are literal geographic and historical records encoded in musical and narrative form, tied to specific features of the landscape that serve as long-term mnemonic anchors. When the landscape changes, as it did when the postglacial sea level rise consumed the Australian coastline, the tradition preserves the memory of what was there before as a record of the change itself. The physical feature is gone, but the information about it is embedded in a structure designed to hold it. The Vedic oral tradition of ancient India developed this principle to an extraordinary degree of formal precision. The preservation of the Rig Veda through oral transmission was not left to general cultural motivation. It was the subject of a professional tradition in which trained specialists spent years learning to recite the texts with absolute accuracy. Multiple independent systems of recitation were developed, including the Ganapatha method, in which each word of the text was recited in combination with the words immediately before and after it, in a complex interlocking pattern that made any deviation from the correct text immediately detectable by anyone who knew the system. This is an error correction system of genuine sophistication, engineered by people who understood that information degrades over time and who built a technological response to that problem. The accuracy of this system has been tested by modern scholarship. The version of the Rigveda preserved in the oral tradition and eventually written down has been compared against the oldest available written manuscripts. The degree of consistency is remarkable. A long and complex text has been transmitted with near-perfect fidelity across at least 3,000 years of oral tradition. Now consider what kind of information the flood memories in this story were preserving. Because this is where the mechanism meets the content. Geographic information is, from the perspective of oral tradition as a memory system, among the most stable categories of knowledge a tradition can carry. A story that says the homeland was to the west, beyond the water, can be checked against observable geography. A story that says the coastline once ran further out than it does now can be checked against geology. The physical world serves as an external anchor that stabilizes the tradition against distortion in a way that purely abstract content cannot be stabilized. This is why the Nunn and Reid finding is so significant for this investigation. They were not simply showing that Aboriginal Australian oral traditions were old. They were showing that the specific mechanism by which oral tradition resists distortion, the anchoring of information to verifiable features of the physical world, functions over timescales that independent science can verify. The oral tradition and the geology were telling the same story independently. The agreement between them is the expected result of a well-designed memory system operating as intended. Now consider the emotional dimension of what the flood memories were preserving, because this is where the mechanism connects to the specific content. The neuroscience of traumatic memory has one finding directly relevant here. Events that threaten survival, that disrupt familiar environments, that separate communities from their landscapes, are encoded with a persistence and vividness that ordinary events do not achieve. They become reference points. They generate the emotional urgency that motivates cultural preservation across generations. The flooding of the coastal world at the end of the Ice Age produced exactly those conditions everywhere it touched. For communities that watched the sea consume the places where their families had lived for generations, the experience was not just a natural disaster. It was the end of the world they knew. It was the event that divided time into before and after. It was the story that explained why the homeland was gone and why the community was where it was instead of where it had been. The grief in the flood memories of the world's ancient cultures is not literary decoration added by later storytellers. It is the emotional signature of real loss, encoded in the traditions because the communities that experienced the loss needed their descendants to understand what had happened and to carry the geographic memory of where it had happened forward into a future those communities could not see. This is a plausible and coherent account of the origins and persistence of flood memories with geographic specificity across the postglacial world. It is not proof that every such memory is accurate in its specific details. Plausible mechanisms do not confirm specific instances. Each instance requires its own investigation against its own physical record. The Aboriginal Australian case has been investigated and confirmed. The Saraswati River case has been investigated and confirmed. The Dwarka underwater structures have been investigated and confirmed in the terms appropriate to what the evidence shows. The Doggerland landscape has been investigated and confirmed. Other traditions, in other regions, have not yet been subjected to the same verification process. The honest acknowledgement of that gap is what separates the confirmed cases from the larger framework of investigation. Not every tradition will prove to preserve accurate geographic memory. Some may preserve memory of local flood events rather than the global sea level rise. Some may preserve cosmological beliefs rather than geographic information. Some may prove, when the physical evidence is properly investigated, to be pointing at real drowned landscapes. We do not know which category applies to which tradition until the investigation is done. The architecture of memory is a real structure that some human cultures built to carry specific information across long time scales. Where that structure has been tested against the physical record, The results have been striking enough to justify continuing the investigation everywhere. The conditions that enabled it may have operated. The traditions preserve the questions. Some of them may have preserved the answers. The work of finding out is what the next chapter describes. Chapter 10. What we are only beginning to ask. The ship is called the RV Belgica, a Belgian research vessel. And on a morning in the spring of 2018, it is running a survey line across the floor of the North Sea, about 40 kilometers off the coast of East Anglia. In water, roughly 30 meters deep, below the hull, acoustic pulses are being sent into the seafloor and returning with information about what lies beneath the sediment. On a screen in the vessel's survey lab, a researcher named Fraser Sturt from the University of Southampton is watching the data come in. And what he is seeing is not the featureless flat seafloor that a glance at a modern map would suggest. He is seeing channels. The channels of rivers that ran through this landscape 8,000 years ago, before the North Sea finished filling and closed over them. He is seeing the outlines of what appear to be ancient lake basins. He is seeing the subsurface architecture of a world that ended before writing began and that has been waiting. Under 30 meters of cold seawater and several meters of sediment. For someone to ask it the right question with the right instrument. This is what the investigation of drowned prehistoric landscapes looks like in practice. Not dramatic revelation. Patient, methodical, acoustically guided inquiry into the sediment record of a seafloor that has been holding its information in silence since the water came. The transformation of what is technically possible in this work over the past 2 decades has been significant enough that researchers who entered the field before it began describe the change as fundamental rather than incremental. 3 technological developments account for most of that transformation. Satellite-derived bathymetry has changed the large-scale mapping of the ocean floor. By measuring tiny variations in the surface height of the ocean, caused by the gravitational pull of underwater topographic features, satellites can now map the broad-scale topography of the entire ocean floor to a resolution sufficient to reveal ancient river valleys, basin formations, and the large-scale features of drowned landscapes at a global scale, without a ship having to cross every point of the ocean. Combined with Glenn Milne's geophysical models of ancient sea levels, satellite bathymetry allows researchers to generate, for any region of the world, a map of where the ancient coastlines ran and how they changed over time. That map is the starting point for identifying where to direct more precise investigation. High-resolution multi-beam sonar deployed from research vessels can map the seafloor to centimeter-scale resolution across large areas in relatively short survey periods. The data these systems produce can reveal individual features at a level of detail sufficient to identify structural remains in many contexts and to select specific sites within a surveyed landscape for physical investigation. The Europe's Lost Frontiers project's reconstruction of Doggerland was made possible by this technology. And the same technology is being deployed in other regions. Machine learning applied to the processing of survey data has changed the pace at which large volumes of acoustic data can be screened. The data generated by modern seafloor surveys is far beyond what any research team could examine manually in a practical time frame. Machine learning systems, trained to identify specific feature types in sonar data, can perform an initial pass through large volumes automatically, flagging candidates for human review and dramatically accelerating the identification of sites that warrant further investigation. These 3 developments together represent a genuine change in what is possible. They do not replace the slow, careful work of underwater excavation when sites are identified and need to be documented. They transform the process of identifying where that work is needed, making systematic coverage of large areas of drowned prehistoric coastline practically achievable in ways it was not a decade ago. Now turn to the specific places where the investigation is most active tonight. In the waters of the Persian Gulf, research teams from institutions in the Gulf states, working with international partners, have been conducting surveys in the areas where Jeffrey Rose's geophysical modeling predicted the Persian Gulf Oasis was located. The surveys are ongoing. Results are being analyzed. The seafloor of a body of water that was a river valley 9,000 years ago is being asked. For the first time, with instruments adequate to the question. What it holds. What those surveys will show is not yet known. The investigation is active and has not yet reached the stage of conclusions. In the waters around the Indian subcontinent, ongoing work by the National Institute of Ocean Technology and the National Institute of Oceanography continues to expand the documented record of submerged structures along the continental shelf. New sites are being identified through combinations of satellite bathymetry, systematic sonar survey, and the accounts of local fishing communities who have described anomalies in the seafloor near their traditional fishing grounds for generations. The picture of what the Indian Ocean shelf looked like when it was inhabited coastal land is becoming more detailed year by year. In the waters of Southeast Asia, surveys in the Java Sea and the South China Sea have begun to map the ancient river systems of Sundaland. The challenges in this region are significant. The seafloor in much of the region is covered by thick deposits of river sediment laid down over the millennia since submergence, which may conceal ancient surfaces beneath meters of post-flooding accumulation. But ancient river channels have been identified on the seafloor. The inhabited surfaces that once lay above those channels are buried. And buried is not the same as destroyed. In the North Sea, the work of the Europe's Lost Frontiers project has been followed by subsequent research aimed at identifying specific sites within the Doggerland landscape where targeted excavation might recover cultural material. Sediment cores are yielding pollen records and plant remains and animal bones that allow increasingly detailed reconstruction of what the landscape was. Ancient DNA extracted from the sediment, using methods developed in the past decade, is beginning to reveal information about the organisms that lived in the Doggerland landscape. In at least one case, this analysis has detected human genetic material in sediment from a context consistent with Doggerland occupation. The result is preliminary and requires further confirmation, but it points toward a method by which the human presence in drowned landscapes might be documented even in the absence of visible structural remains. There is one more dimension of the current investigation that belongs in this chapter: the techniques that have recently transformed the reading of damaged ancient texts, the multispectral imaging that recovered text from the Sinai palimpsests, the virtual unwrapping and machine learning analysis that allowed the Herculaneum scrolls to be read without physical unrolling, represent a broader pattern. Improving technology changes what can be learned from evidence previously considered too damaged or inaccessible to yield information. The category of unreadable is not fixed. It contracts as the tools improve. The same principle applies to the underwater archaeological record. Environmental DNA from sediment samples is being used to reconstruct past ecosystems with a specificity that was not possible before the relevant methods were developed. Isotopic analysis of material recovered from the seafloor is providing information about ancient climate and diet and migration. Each of these methods extends what can be learned from the drowned prehistoric world beyond what was possible even 5 years ago. The investigation is not a question with a fixed and final answer waiting to be confirmed or denied. It is a field in formation, building its methods and its evidence base year by year, asking its questions with increasingly capable tools, and assembling a picture of the human past in coastal environments that the standard timeline could never have generated from land sites alone. Fraser Sturt on the RV Belgica is looking at river channels that nobody has seen since the Storiga tsunami swept across them 8,000 years ago. He does not know yet exactly what those channels will reveal. He knows what questions to ask of them, and he has the tools to ask. That is enough to keep working, and the work continues tonight. In the cold water above ancient coasts, in the patient accumulation of data, that is, one survey line at a time, drawing the map of a world that the standard timeline forgot to include. Chapter 11. The map is still being drawn. Come back to the beginning. Not to the beginning of this story, to the beginning of the question itself, to the person standing on the shore, Looking at the water, understanding that something is gone beneath it. We began there. We end there. Because every thread of this story leads back to that moment. To the human being at the edge of the sea, who looked out at the water covering the place where their grandparents had lived, and decided that what they had witnessed needed to survive. They made it into a story. The story survived. Now, hold in mind the full picture that this investigation has assembled, because this final chapter is not a conclusion. It is an accounting, honest and precise, of what we know, what we have reason to investigate, and what remains genuinely open. Begin with what is confirmed, because the confirmed findings are more remarkable than they are often given credit for being. Doggerland was a real inhabited landscape in the North Sea, one of the most ecologically rich environments in postglacial Europe, home to communities of significant size, completely gone beneath the sea, approximately 8,000 years ago, and completely unknown to modern scholarship until trawler catches and geological surveys, and eventually Gaffney's project began to reveal it. It is now mapped in geophysical detail. The Storega tsunami that ended much of it left a layer of deposited material in the seafloor sediment that researchers have found and dated at multiple locations. The world was there. It is documented. The Saraswati River was a real geographic feature, described with geographic specificity in the Rig Veda. Its existence confirmed by satellite imagery of dried river channels in what is now desert. A civilization flourished along its banks. The Sanskrit tradition preserved the memory of it across thousands of years. Independent scientific evidence confirmed that memory, the Dwarka underwater structures, are real, accepted by the Archaeological Survey of India, confirming that the oral tradition of Dwarka as a coastal city consumed by the sea was preserving the memory of a real coastal settlement. The structures date to the known historical period, not to the Ice Age. Whether earlier layers exist beneath them is an open question. The Aboriginal Australian oral traditions documented by Nunn and Reid preserve accurate geographic information about specific changes to specific Australian coastlines, verified against the geological record, across timescales of 7,000 to 13,000 years. The mechanism by which this was achieved, structured oral tradition anchored to verifiable landscape features, is documented and understood. The Mahabalipuram underwater structures confirmed that a local oral tradition pointing at a specific underwater location was describing specific physical contents that were actually there. These findings are real. They establish that the category of questions this story has been asking deserves to be taken seriously with the best available tools. Now consider what is a genuine open question, supported by solid grounding but not yet confirmed by the physical investigation that would be required to settle it. Jeffrey Rose's Persian Gulf Oasis hypothesis. Grounded in geophysical data about the bathymetry and paleoclimate of the Persian Gulf, consistent with the Sumerian oral tradition and the geographic distribution of the oldest Mesopotamian cities, not yet tested directly by systematic survey of the Persian Gulf floor. The question of whether Austronesian oral traditions in Southeast Asia are preserving geographic memories of the flooding of Sundaland, comparable to what Nunn and Reid documented in Aboriginal Australia, suggested by preliminary research, not yet established by an equivalent verification process. The question of what the submerged continental shelves of the Indian Ocean, the Arabian Sea, and the shallow seas of Southeast Asia contain from the period before the post-glacial sea level rise. Investigations underway. Results not yet at the stage of conclusions. The question of what the shallow shelf areas, west of Gibraltar, where ancient coastal land went under the sea at the end of the Ice Age, might reveal if systematically surveyed. Not yet asked with the right instruments. These are not questions that have been asked and answered in the negative. They are questions that have not yet been fully asked. Their answers are genuinely unknown. And then there are the things that sit at a different level of uncertainty. The Atlantis account in Plato, whose origin remains genuinely uncertain and whose specific claims cannot be confirmed from the available evidence. The Yonaguni Monument, whose natural or artificial origin remains unresolved. The Piri Reis Map, whose most controversial interpretations are probably wrong, but whose documented claim to ancient source maps raises real questions about geographic knowledge transmission that the history of cartography has not fully resolved. These are interesting questions. They require more evidence before they can support conclusions. They should not be pressed into service for claims they are not strong enough to support. 3 layers. What is confirmed? What is genuinely open and well-grounded? What is interesting but uncertain? Keeping those layers clearly separate is the only honest way to represent the state of this investigation. Now, step back from the accounting and think about what it means that the investigation is as early as it is. The standard timeline of human civilization was built over more than 2 centuries of archaeological work, conducted almost entirely on land, by generations of researchers who were asking good questions with the tools available to them. It is not wrong. It is incomplete in a specific and important way. The most ecologically favorable coastal environments of the ancient world are now underwater, and the evidence from those environments has barely been examined. The investigation of drowned prehistoric coastlines is not a correction to the standard timeline. It is an extension of it, into the domain that the standard timeline could not reach. What it finds will not overturn what is known from land sites. It will add the chapters that the rising sea removed from the record. Those chapters are still there, not in myth, not in speculation, in the sediment and the sediment-buried structures and the ancient DNA preserved in the cold, dark water of the shallow seas above the world's drowned prehistoric coasts. The researchers who will find them are working tonight. Some of them are on vessels like the RV Belgica, sending acoustic pulses into the seafloor of the North Sea above the ghost rivers of Doggerland. Some of them are in laboratories, processing sonar data from the Persian Gulf and looking for the patterns in the geometry of the seafloor that would indicate something worth investigating further. Some of them are sitting with elders in coastal communities, listening carefully to descriptions of what lies beneath the water near shores their families have fished for generations, writing down the geographic details the way Nunn and Reid wrote down the Aboriginal Australian descriptions and then checked them against the geological record. They are not looking for Atlantis. They are looking for the coastal world that the postglacial sea level rise consumed. The world that was home to the people whose descendants preserved the memory of it in stories that survived 10,000 years of transmission, precisely because the people who carried those stories understood that the memory was too important to lose. The map that does not belong to any single civilization was never a map of a single place. It was a map of a kind of loss. The loss of the coastal world that existed before the ice melted, drawn in the specific geographic terms of each culture that experienced it, carried forward in the specific traditions each culture developed to hold its most important knowledge across time. The traditions preserved the questions. The seafloor is beginning to answer them. Let your breathing slow now. The work is happening without you. In the quiet hours of the investigation that most of the world does not see and does not know about. But that is moving. One survey line and one sediment core and one verified oral tradition at a time, toward the picture of the world that the water took. You do not need to hold the question tonight. It is being held by the researchers and the instruments and the patient accumulation of evidence that is, slowly and carefully, and with the full weight of the best available methodology, drawing the map of the world that existed before the ice melted and the sea came in. The map is not finished. It may never be finished. The ocean is large and the work is long, and the questions the seafloor holds may take generations to answer fully. But every survey line adds something to the map that was not there before. Every sediment core recovered from the floor of a sea that was once dry land is a message from a world that has been waiting 10,000 years to be heard. Every oral tradition checked against the physical record and found to be accurate is a voice from the past that crossed 10,000 years of silence to reach us. The map is still being drawn. And somewhere in the shallow water above an ancient coast, in the darkness, below the surface of a sea that was once a valley or a plain or a river mouth, where families built their lives, the world that every coastal culture remembered is keeping its record. Patient, dark, present, waiting for the question that the right instrument, in the right place, in the hands of the right researcher, will finally be able to answer. Sleep well. Dream of coastlines. Good night.